In this lesson, we're going to cover two different types of motion constraints and a transitional assembly constraint as well. The file that I have open currently is called motion.iam, and it can be found in your Chapter 6 exercise folder. You'll see in this assembly here that I have these two pulleys. If I grab them and drag them, you can see that they're going to move independently. And obviously what I would like to have happen as one of them spins around, I would like the second one to spin as well. From the assembly panel, I'm going to scroll on down and click on the constraint tool. And then I'm going to select on the motion tab. And I have two different motion types. The first one is going to be a rotation. So what I'm going to do is I'm going to select my two pulleys. And right now the ratio is at 1 because they are the exact same diameter. So now as I take that first one and spin it, you'll see that the second one will spin. And it doesn't matter which one you grab. And you can edit these constraints as well. So if I right click, edit. If for some reason you wanted to, you could reverse the direction, and you could make the ratio different. In this case, there'd really be no reason to do that, but you can. So as one spins, the other one is going to spin half as fast. So let's close that file. And the next file that we're going to work on here is going to be the gears.iam. And what we have with the gears.iam file, also found in your Chapter 6 exercise folder, if I spin the model around a little bit, you can see that I have these two gears. And the same scenario, as this first gear spins, I would like the second one to spin. And again, we'll set up a ratio between them. So again, I'm going to select the constraint tool. Again, go back to the motion tab. And again, we're going to use the rotation option. I'm going to select the first gear, and let's get in tight. We'll select the second gear. And for the ratio in this case, it's going to be 0.5 because I want that second gear to rotate half as fast as the first one. In this case, they'll go in the same direction, so go ahead and click OK. So now as I come back and drag the first one, you can see that the second one is moving. And if I spin the second one, the first one is going to move as well. So that's really all there is to that. Let's go ahead and close that file. And the next one that I want to work on is going to be the Arbor press. And what we have in the Arbor press, as the vertical arm goes up and down, I would obviously like the handle to rotate, and right now you can see that they're spinning independently. So first of all, what I'm going to do is I'm going to grab the three components that I want to work with, and I'm going to right click and I'm going to click on isolate. So now I have a lot cleaner screen to work with. So let's just prove that again. So as I take that back and forth, you can see nothing is happening. They're just moving independently here. So again, we'll apply a constraint from the motion tab. In this case, though, however, we're going to use rotation translation. So for the first one, this is going to be the object that's going to be the driver. In this case, we're going to select our diameter. And for the second one, we're going to select our vertical plate here. And you'll see that it already placed in a value of 3.68. For the one revolution, the vertical arm here will travel 3.68 inches. So let's go ahead and click OK. Now as I grab that arm and spin it, you can see that it's going to rotate. And let's just pull the vertical arm up as well. So it doesn't matter which one you do, but you can see that it's definitely traveling as we told it to do. For the last exercise here, I'm going to switch back over to the last one, which is the transition.iam. And what I want to do in this case is I have this pin, and I want to take this pin and have it slide around the cutout that I have here. So first of all, what we're going to do is we're going to apply a constraint. And let's start off by applying a flush constraint between those two faces. Go ahead and click apply. And then we're going to go back over to the transitional. And for this type, I'm going to select our pin. And then for number 2, I'm going to select one of the inside faces. It doesn't matter which one I do. Click OK. So now as I rotate, or just grab that part and move it along, you can see that it's staying tangent to all those faces. Let me spin it around so you can see it maybe a little bit better from a top view. And I'm just dragging it along, and it will always stay right on that cutout.